Hello everyone, welcome back to JDCodebase. Today we are solving LeetCode 122 best time to buy and sell stock part 2 from this LeetCode top interview 150 series. And this problem looks very similar to LeetCode 121, but the rule change here make a huge difference and many beginners get confused here, so don't worry, we will go very slowly and understand everything clearly. So let's first understand the problem in simple words. You are given an array called prices, and each element represents the stock price on that day. You can do as many as transaction you want, which means you can buy a stock, you can sell a stock, then again buy, then again sell. But there is only one rule you must remember. You cannot hold multiple stock at the same time. So before buying again, you must sell the previous stock. Our task is simple: return the maximum profit we can make. So let's understand this with an example. Here prices are 715364. Now notice something important. We are not trying to find only the best one best buy, one best sell. Here buy at 1, sell at 5, profit is 4. Buy at 3, sell at 6, profit is 3, and total profit is the 4 plus 3 is 7. And this is allowed because we sell before buying, so the output is 7 here. So these are the normal constant, and array length can be large up to the 30,000. And so if we write a very slow solution, it will fail. That's why optimization is matter. Now let's talk about the brute force approach, a first approach. So think like a beginner. What is the most straightforward idea? The idea is try all possible ways to buy and sell. On each day we have 3 choices: buy, sell, or skip. So we try every combination using the recursion and take the maximum profit. So this approach helps us understand the problem, but it is very slow because the same calculation repeat again and again. So here is how the brute force logic works, the algorithm. So we start from a day I, and for every future day j, we buy on day I, we sell on day j, and after selling we again calculate profit for the remaining days using the recursion. And finally we return the maximum profit we can find. This solution is the correct logically, but performance wise it is very bad actually. So let's try run with a small example. The price is the 1 2 3. Possible transaction is like buy at 1, sell at 2, profit is 1. Buy at 1, sell at 3, profit is 2. Buy at 2, sell at 3, profit is again 1. So among all these, maximum profit is 2 if we calculate 1 plus 1 2, if we just is 2. So brute force gives the correct answer, but imagine doing it this for the 30,000 days. It will be extremely slow. So let's move to the LeetCode and write the solution for this. So first we will use a helper recursive function. This function tells us the maximum profit starting from a given day. So function helper and the start. So this maximum profit means if we reach the end of the array, there is no profit, means the edge case of this recursive function means start is the greater than equal to prices dot length and return 0. So here the this function this start is here the day means at what index means 0 1 2 3 4 5 6 this day. Next we create a variable to store the maximum profit. Let maximum profit is equal to 0. And now we loop from the current day for let I equal to start I is smaller than prices dot length I plus plus. And for every day we try selling on future days, let profit equal to 0. And for future days means for let j equal to I plus 1. J is smaller than prices dot length and j plus plus. And now if selling price is greater than the buying price, we calculate profit. Means if prices of j is greater than prices of I, then profit becomes prices of j minus, not double j, prices of I. And we have to again add the helper function for next upcoming days, j plus 1, and also update the maximum profit here. Maximum profit is equal to math.max max profit or profit. So now pay very so give the very close attention here, because this is the most confusing line in the brute force solution, and it is very important to understand it properly. Inside the loop we are using that we buy on the day I, means at the ith index at the I day, and we sell on day j. So this part is simple, there is no issue. And prices of j minus prices of I, calculate the maximum price means profit, and this is the profit of only one transaction. Listen carefully, this is the profit of only one transaction. But in this problem, are we allowed to do only one transaction? No, we are allowed to do multiple transactions. So after selling on day j, we are not done, we can again buy and sell in the remaining days. So that is why we add this part plus helper j plus 1. So now let me explain what helper j plus 1 means. Helper j plus 1 returns the maximum profit we can make starting from the next day after selling. So this line means profit of current buy and sell plus profit of all future transaction. Means if I purchase at the day 1, means at the at the 1, and buy and the sell at the 5th, means I get the profit 4. But on next day, how can I move? For that I have to use this helper j plus 1, means j plus 1 I purchase at the 3 and sell at the 6. So let's write the means let's return the here answer, means return maximum profit. And in last from the main function we have to return, call this helper function with the starting index 0. So let's run this code. Yes, it is accepted. Let's try to submit this. See, I got the TLE. Again, this code is just for understanding. You should never use this in interview, because time complexity is here the exponentially, and space complexity is the big open due to the recursion step, and this solution get the TLE also. So let's move to the optimal solution. The here is the key observation: if price is going up, we make the profit. If price is going down, we do nothing. Instead of finding one big transaction, we take the all small profit, and this work because multiple small profit together give the same result as one big transaction. So the idea is the heart of this problem. Means, so this algorithm is very simple. Initialize the profit is equal to 0 and start from the day 1. If the today price is the higher than the yesterday price, add the difference to the prices of I minus prices of I minus 1 to the profit, and finally return the profit here. So let dry run with the 1 2 3 4. On day 1 buy, on day 2 sell, profit is the 1. On day these two, on day 2 I purchase, I sell 1. On day 3 purchase, sell 1. So total profit is 3, means not day 2, because on one day I only select either purchase or sell, so I get the profit by 2 here, not 3 I think. Yes, on every day I purchase, I sell, means on next day, and get the profit. So yes, it's 3 here. So we are buying and selling every day internally, but logically it follows the rules. Yes. So let's write the code for this. So first make a variable, create a variable to store the total profit. Let profit equal to 0, and we start from the index 1 because we compare with the previous day. For let I equal to 1, I is smaller than prices dot length and I plus plus. So if today price is greater than the yesterday price, we add the difference, means if prices of I is greater than prices of I minus 1, then profit is plus equal to prices of I minus prices of I minus 1. So, and finally we have to return the profit, return profit. So let's run this code. Yes, it works. Let's submit the solution. So this solution looks simple, but understanding why it works is more important than memorize it. So time complexity for this is the big O of n as a single one for loop, and space complexity is also big O of 1. So this is the best solution for interview. So let's quickly compare both the solution. Brute force solution is the slow one, and exponentially the time complexity, and not a interview useful. But optimal greedy solution is the fast, big O of n, time complexity, space complexity is the big O of 1, are very important for the interview. So thank you for watching this video. If this explanation helped you, please like, share and subscribe to JDCodebase. See you in the next LeetCode top interview 150 problem.